All right, hello everyone. Welcome to my channel. On this channel, we do primarily educational material, and today is the 124th video that we have done on the reciprocal system of theory. This is a system of theory, or a theory of everything, that was derived by Dewey B. Larson back in the 20th century up until his death in 1990. He worked on his theory for about 60 years and started writing books in the late 1950s and wrote 12 to 15 books and many, many articles on the reciprocal system, from all the way from uh, physics and astronomy to chemistry to economics to metaphysics, including religion and dream interpretation and uh, philosophy. The key in the reciprocal system, and what I love about it the most, is that it is a leveling force. It allows you to become the scientist. You do not have to kowtow to the white lab coats guys telling you how things are. You can figure it out for yourself if you understand the theory well enough. And that was Larson's thing. He believed that the theory itself was correct. Now, whether he applied it correctly in every situation was a different matter. And he did make some mistakes, and some good folks came up behind him and proposed many very important corrections to those mistakes, and we will get into those eventually. The basics behind Larson's theory is that we live in a universe of motion, not a universe of matter and not a universe of energy, but a universe of motion. Matter and energy are merely specific kinds of motion. And motion for Larson was the relationship between time and space. And that was a reciprocal relationship, basically meaning that motion is a fraction, with time as the numerator and space as the denominator, or vice versa. Time and space can come in 1, 2, or 3 dimensions, maybe even more. And they both, as all reciprocals, have the same quality. Same way that 2 halves and 3 2/3 and 3 halves have the same qualities of 2 and 3. Motion, space and time both have the same qualities as parts of motion. They are multidimensional. Larson calls that coordinate time and coordinate space, 3 or more dimensions. And they both flow and progress. Larson calls that clock time and clock space. Time is always getting later and later and later. Space is always getting farther and farther apart. We've seen that in the Hubble telescope's recession of the distant galaxies. And space and time both are coming in discrete units only. They're not continuous. They come in chunks. Discrete units. The minimum unit of space is about 4.5 times 10 to the minus 8 meters. Microscopic, but very large compared to like the size of an atom. And the unit of time is even smaller, 1.5 times 10 to the minus 16 seconds, meaning that there are 6.6 quadrillion units of time in 1 second. 6.6 quadrillion is a million billions. Okay, now when you have 1 unit of time, 1 unit of space in 1 unit of time, what you have is the speed of light. And so for Larson, for Einstein, the speed of light was the maximum speed of the universe. But Einstein's universe was a static universe, where the 0 point is really zero motion. Whereas in Larson's system, we have a universe of motion. So really the origin and the background, the null point, the neutral point is actually still in motion. It is a motion. And so in Larson's universe, half of the universe is actually moving faster than the speed of light. The speed of light is the midpoint, and then half of the universe is moving slower than the speed of light. Larson calls those the material sector and the cosmic sector. The cosmic sector moving faster than the speed of light. He also calls it sector 2 as opposed to sector 1. Okay, so now what we're doing here is we are just reading over one of his interviews, one of the few interviews that we have from Larson back from 1984 when he was 85 or 86 years old. And he's just talking about the development of the theory, how he went about it, what happened at what time period, how he got it through, what the reaction was, how he made corrections, all these different things. And we just got done how he was talking about how in many cases he would be attractive to the students at a university, but when he came to speak, it was usually over the opposition of the faculty. So the students wanted to see him, but the faculty would, oppose it. And but that he did catch on with a few, especially in England, a few student groups, and even a couple faculty members at a few of the colleges there, and was able to make some correspondence. And this was back in the 60s. And that caused him to work on this liquid state papers. And incidentally, the states of matter were very, very important, are very, very important to Larson's system. They are more archetypal than anything. And you can see that just in general metaphysics. Earth, air, water, and fire are, really just, you're just talking about the states of matter. You start talking about solid, liquid, vapor, and gas. But Larson here is saying that the condensed gas state is the fourth state of matter. In other places, he does say that the vapor state is really the fourth state. And then you might have this condensed gas state, or whereas this plasma state that other people are talking about is more of an ionization state. Okay, now we'll take over right here with the questioner. It seems to me that you've done much. You've done so much on the liquid state that it merits another volume by itself. Larson, well, I don't know if I'll ever get to that or not. Question, you don't think you could publish it as it is? Larson, I don't. Too many things now I didn't know 30 years ago, so I wouldn't want to publish anything that I wrote then as of today. Question, you could publish it as something that was written 30 years ago. Answer, Larson, yes. You could tell them that this was written 30 years ago and I don't agree with it all now, but that doesn't go down very well. Question, I suppose it's a question of priorities with so much new data coming in all the time from the research laboratories and the space probes. Larson, so many things come along that I think would be of interest from the standpoint of the way they fit into the theoretical picture. For instance, I've read that they claim to have created in the laboratory the kind of degenerate matter that they have in the white dwarfs. Their evidence for that was that ordinarily when you collide these particles, they bounce off each other in all directions, but they got up to a critical energy level at which some of the particles, as they reported in this report that I saw, that some of the particles stuck together and for a very short period of time. and then separated. And they attributed that to being this degenerate matter during this period of time. That's just exactly what you would expect theoretically from my development. Let's assume they got to the point where they were able to give a greater than unit velocity to some of these particles. They would immediately start moving apart, not in space, but in time. And to the investigators, they would appear to be sticking together. Question. There are many other items, new discoveries, and new theories, like the gravitational lenses, that need to be explained. Larson, regarding the gravitational lens, I don't think we have enough information to decide what the answer is, but I would be more inclined to think that it is not a gravitational lens, but something analogous to the two images that we see on the radio image of the quasar. Incidentally, Larson has a book that's called Quasars and Pulsars, and he has a few articles that came out before that. He actually predicted the existence of quasars several years before they were actually discovered, observationally. And he predicted many of their qualities in detail. And so, again, he's using his system of theory and then using deductive reasoning. If this, then that. If this, then that. Then he is able to construct a theoretical universe. Okay, another advantage that this has is that, when you're talking about NASA or whoever, they're using billions and billions and billions of dollars to do their various things, and they're not even able to keep up with Larson on his $50 budget or whatever, to buy a slide rule and pencils and paper. So yeah, the power of the reciprocal system of theory is it enables you to construct a theoretical universe. And then you can compare it, like Larson did, with the actual universe that's been measured and observed. The problem that Larson actually got into is that the comparisons that he made with the he was naive in a general sense, in that he thought that the measurements that he was getting from the scientists were accurate, and in many cases that even their empirical measurements and observations were wrong. And so he was comparing his theoretical universe to a universe that was already wrong, and that's why he made some mistakes. Anyway, back to Larson. I think there should be more effort made to get people to write in questions that they have in mind. The problem is not in getting the answers, but in getting the questions, getting people to write in about things they're genuinely puzzled about. Question. Obviously, there are a lot of things people don't understand, such as the interregional ratio problem that came up at the conference here. Hardly anybody could explain how that's generated. The interregional ratio is one of Larson's things in his system, and it's basically there are different sectors of the universe, just like sector 1 and sector 2, divided by the speed of light. But when you're comparing measurements going across these boundaries, you basically are just saying, I can't see everything on the other side of that boundary. My resolution only enables me to see a certain fraction or certain percentage of what's on the other side of that boundary. And so what I observe has to be reduced by the interregional ratio, by the ratio of what I see to what I would see if I were actually on the other side of that boundary. It's kind of like if you looked at the sun, you look at the sun, you're recognizing that you're only seeing what's on the surface. You're not seeing the inside of the sun. You're seeing the surface. And so you have to kind of adjust your your observations to account for the fact that you know that you're not seeing the whole thing. Okay, Larson, I don't think that people who are asking that question realize that they're asking us to do something that the conventional theory doesn't even attempt to do. The interregional ratio is not different from any other physical constant. It's just the same as the gravitational constant or the gas constant or anything else. Conventional science doesn't try to explain where they came from. It doesn't even tell us that they have any meaning. So actually, these fellows ought to forget that for the time being. If they can't see where it comes from, never mind. Take that as a given, just as they would have to do if it were anybody else's theory. And wait until they understand the theory before they get into the depths of these things. Exactly. People are so willing to shoot holes in Larson's theory and anybody else's theory that's outside the paradigm when they don't even do that for the legacy science. They get a pass. They can come up with all kinds of garbage and it doesn't get questioned. But Larson comes up with something similar, and it's the death knell of his theory. Whereas if the legacy scientists come up with it, it's just a shrug of the shoulders. Oh yeah, well, I'm sure they know what they're talking about. I'll figure that out later. Just in order to really get into the reciprocal system of theory, you have to give him a little bit of a pass and just say, I don't really understand this well enough to be critiquing it quite yet at this point. I need to dig in a little bit more, and really see where it's coming from. Because if you read Larson's books, you will understand that he uses the interregional ratio absolutely consistently with every subject that he applies it to. And you can see that, but the only way that you can see it is if you've read several of his books and see that his approach is consistent every time. And so he's not just making like a fudge factor in order to get the right answers or whatever. He's using it consistently because he believes that that's the way that you apply this particular thing. Okay, question. They think it's the key to understanding the theory. That's why they're so worried about it. Larson, but it isn't. It's like saying you've got to understand the gas constant before you can understand chemistry. Well, nobody understands where the gas constant comes from. Question, did you arrive at the interregional ratio as a deduction from the postulates? Larson, no, I measured it, just like they measure the other constants, and then I tried to find out how it relates to the rest of the theory, just like I did with the gas constant. Question, so extending the theory basically involves explaining observed phenomena. Larson, that's only a small part of it, but one case struck me particularly. My findings all along have required that the galaxies would pick up some of these globular clusters while they were still premature, while the stars hadn't formed yet. That, of course, meant that some of these clusters had to be in the galaxy somewhere, but there wasn't any evidence of it. Nothing in the textbooks about it. Now, the astronomers find evidence that of these big dust clouds, which are just the thing that I had been looking for. And not only that, but they find that there are, as they say, clumps inside these clouds that are denser than the rest of them, which obviously are the stars that haven't made it yet. So the whole thing fits like a glove. Question. I have a few questions about your unpublished manuscript Beyond Space and Time. We went over that, the whole thing, over about 90 videos just before this. This is his book on metaphysics. It didn't come out until after he died. So apparently here at this time in 1984, he had already pretty much written it up, but he kept it unpublished. So I want to talk about your unpublished manuscript. beyond space and time. It seems to me that you left a lot of questions unanswered in that part, in the part that deals with biology. Larson: oh yes, certainly. How cell division takes place, for example, how the inverse sector enters into that, or the cosmic sector enters into that. It might be useful in solving some problems in medicine, cancer being uncontrolled cell division. Larson: well, in essence, it's a handle on something. Whether it's a handle on anything useful is another question, but it's a handle. And that, of course, is the thing that is the most difficult in research work, to get a handle. Question: I'd be interested in pursuing that, except my qualifications aren't adequate at this point. Larson: I suppose I'll have to publish that thing pretty quick whenever I get around to a way of doing it. Okay, so this is evidence that Larson was intending to publish Beyond Space and Time. A lot of his followers kind of were disappointed in his wife, his widow, for publishing Beyond Space and Time after he died. And they would argue that Larson would have never wanted to publish this book because Larson was a hard-headed scientist. He was, doing hard science, and he wouldn't want this fluffy woo-woo to be published. But here he's saying, I'll have to publish that thing pretty quick whenever I get around to a way of doing it. This was 6 years before he died. Apparently he never managed to do it in his lifetime, but his wife did it a few years after he died. Question: does it need any more revision? Larson: no, probably not much. Question: you say in the preface to that book that it's something very urgent, so I think maybe there is a case for getting it published. Larson: it becomes urgent when I say so. But you see, I will have to publish it now because I have prepared the way in this astronomy book. I don't spring it out all of a sudden. I lead up to things. Well, what I say here, the effect of the new information derived from the theory of the universe of motion on our understanding of the relation of the human race to its physical environment, has been explored in connection with an extension of the physical investigation into the non-physical fields, the results of which will be reported in a separate publication. That's in answer to item number 7. My item number 8 is, are we alone, or is there intelligent life elsewhere in the universe? Remember that question 7 was, is the human race part of a machine, or does it in some sense have an independent role? What I read to you is part of my answer. Now, in answer to this question, is there intelligent life elsewhere, I can say this: the theory opens an avenue of approach to these issues. A preliminary study along these lines has been included in the extension of the physical investigation that was mentioned in the answer to question 7. Then I end the whole thing with the discussion of question 10. Is there anything outside the process that is independent of the universe of motion? And the last paragraph of the answer to that is the last paragraph of the book. The findings of the extension of the investigation of the physical universe into the non-physical region are much too voluminous to be included with the physical results, but will be described in a separate publication. But it would not be appropriate to conclude the discussion in this volume without calling attention to the manner in which the clarification of the properties of the physical universe sets the stage for a confirmation of the reality of existence outside that universe. The more complete understanding of physical existence opens the door to an exploration of existence as a whole, including those non-physical areas that have hitherto had to be left to religion and related branches of thought. It is now evident that our familiar material world is not the whole of existence as modern science would have us believe. It is only a part, perhaps a very small part, of a greater whole. Now, that ought to be enough of a teaser, no? Okay, we will stop it there and we'll take over tomorrow. Thanks for tuning in. Have a great day.